Hi everybody, this is an overview of the research work I've been doing during the last year, which focused on visual perception and bridging the sim to real gap. I started the year by wrapping up my grade work. It's a fully open source framework based on Isaacson that allowed me to streamline online and offline robot testing and data generation through a customized and flexible simulation tool. I used that for running robots in different realistic worlds populated with animated dynamic assets, while generating both richly annotated high-fidelity images and physical ground truth information. Then, I benchmarked visual SLAM methods, ran multiple robot experiments, and tested its visual realism and sim-to-real transfer capabilities. This work is currently under consideration for Science Robotics, and I presented part of it at 2 iCraft workshops last year. Thanks to those testing, I noticed 3 main issues with current dynamic visual SLAM methods. The first one is that they over-rely on already available datasets, thus failing to generalize. Then, they do not report the tracking rate, which is an essential metric to evaluate the robustness of such methods. And then, they discard too much information by blindly thresholding and segmenting predetermined dynamic objects. This sparked the idea behind Dynapix. This system, which I developed with Cheng-Hao Xu, seeks to generate a motion probability map for every frame. We obtained that through a combined process that utilized background synthesis, image differencing, and splatted views, which, once combined, provide a pixel-wise moving probability distribution that is then integrated as is in the SLAM backend. Using our method, we modified both OrbSLAM2 and DynaSLAM and successfully showed lower trajectory errors and higher tracking rates for both simulated and real-world experiments. But grade was not only made for SLAM. In this case, the problem was detecting zebras from aerial imagery as we seek to monitor their behavior without interfering with them. However, zebras, as well as other animals, are underrepresented in currently available datasets, especially if you consider our particular viewpoints. Indeed, the pre-trained models do not generalize well to our data, failing to detect the animals in our sequences. One way to approach the problem is clearly to manually label the images, which is, however, a very expensive operation. My approach, which I presented at the last European Conference on Mobile Robots, instead was to use grade to generate synthetic data, which I used then to train a YOLO detector. We showed, with this method, accuracies that went over 90% by training the models from scratch, without any pre-training or real-world information, so by using synthetic data alone. As you can see from the video, the model pre-trained on the COCO dataset is practically unusable, with misdetection and with misclassifications. Instead, the model trained on synthetic data is already quite stable, while the model trained on mixed synthetic and real-world images has overall clearly the best performance and it's the most flexible one. With this, I want to remark that all our paper and data are already publicly available for free, and if you are curious or you have any question, you can check either my Scholar, grades project page through LinkedIn or email. Thank you.